Alright, problem 2. And what a cleverly titled problem it is. Part 1 of problem 2 asks us what is 2 to the 2013 Model 11, and that gives us the hint to look for a little theorem from class. Specifically, we're looking for Fermat's little theorem, or Fermat's little theorem, if you want to be pretentious, and why not? Fermat's little theorem not a capital L. It's marked, didn't belong there. Ignore my handwriting. Fermat's little theorem tells us, oh god. Fermat's little theorem tells us if P is prime and A is not a multiple of P, then A to the P minus 1 equals 1 mod P. We saw a proof of this in lecture. There's proofs of this in your notes. There are proofs of this online. If you want to find more general theorems that this follows from, you can look for proofs of the Euler-Fermat theorem or Lagrange's theorem in group theory. But the proof doesn't matter right now. So what I'm going to talk about is how to use this theorem for this problem, which is actually quite straightforward. The point is, 11 is prime. I assume you all know how to check that for yourselves. Go ahead and test it out if you don't believe me. 2 is not a multiple of 11. I hope you all know how to check that. Bust out a calculator if necessary. What that tells us is that 2 to the 11 minus 1 equals 1 mod 11. That's an instance of Fermat's little theorem, which is true. 2 to the 10 is 1024, which is 1 plus 1023, which is 1 plus 93 times 11. 2 to the 10 is 1 plus a multiple of 11. So what? So 2 to the 2013 is 2 to the 10 times 201 plus 3, which is 2 to the 10 to the 201 times 2 cubed, which in mod 11 land is, well, first we have a product of 201 factors, each of which is equal to 1 mod 11. So each of those factors we could replace by 1 in mod 11 arithmetic to get a result which is the same in mod 11 arithmetic. This argument I just gave, note, it tells us we can change the base mod 11 to get a result which is the same mod 11. It only applies to the base, not the exponent. But there you have it. 2 to the 10 to the 201 is equal to 1 to the 201 mod 11, because 2 to the 10 is equal to 1 mod 11. So 2 to the 2013, which is 2 to the 10 to the 201 times 2 cubed, is as good as 1 to the 201 times 2 cubed in mod 11 land, which is as good as 1 times 8. 1 to the 201 is, of course, 1, because any power of 1 is 1. 2 cubed is 8, because you can multiply 2 by 2 by 2 and get 8, which is 8. 2 to the 2013 is 8 mod 11. For part 2 of problem 2, we're going to build upon this same idea. We know that 2 to the 5 to the 2013 is going to equal 2 to the m mod 11, where m equals 5 to the 2013 mod 10. This is by the idea from part 1. 5 to the 2013 is something times 10. I don't know, let's call it k, plus that remainder, m. So 2 to the 5 to the 2013 is 2 to the 10 to the k times 2 to the m, which is 1 to the k times 2 to the m in mod 11 land, which is 1 times 2 to the m, which is 2 to the m. Alright, that's just the same idea from part 1. So all it boils down to is we have to figure out what 5 to the 2013 mod 10 is. So we see an interesting result here. The exponent can't be reduced mod 11, but the exponent can be reduced mod 10 if we want the result mod 11. Alright, well, what is 5 to the 2013 mod 10? Well, if you play around a bit, if you imagine that it was an earlier year, a much earlier year when this problem was asked, you might say, well, what is 5 to the 2 mod 10? Well, that's 25 mod 10, that's 5. What is 5 to the 3 mod 10? Well, that's 125 mod 10, that's 5. There's a general pattern here. Any positive power of 5 is 5 mod 10. And you can prove that by induction very quickly, right? 5 to the 1 equals 5 mod 10, or simpliciter. And 5 to the n plus 1 equals 5 to the n times 5, which equals 5 times 5, which is 5 mod 10, if we use as our inductive hypothesis that 5 to the n equals 5 mod 10. So you can very quickly prove that 5 to any positive integer is 5 mod 10, and therefore 2 to the 5 to the 2013 equals, let me move this down a bit, 2 to the 5 to the 2013 equals 2 to the some multiple of 10 plus 5, because 5 to the 2013 is some multiple of 10 plus 5 by that inductive proof we just saw, equals 2 to the 10 to that factor k times 2 to the 5, which in mod 11 land is just 2 to the 5, which is, sorry, not 3 squared, which is 32. And of course 32 is as good as -1 or 10, whichever you like. Just simplifying it there, nothing wrong with just saying 32 itself. Of course, there's nothing wrong with just saying 2 to the 5 to the 2013 either, but perhaps the simplest way of putting it is this is -1 or 10 mod 11. So the answer to part 2 is 10 or -1, whatever you like. They're all good.